In Chapter 6.3, what we're going to learn now is how do you graph linear equations. First of all, what's the definition of a linear equation? A linear equation is where you have a single power of the variables x and y. If you take x to the second power, in other words x squared, now you've got a quadratic equation, and we'll graph those towards the end of our semester. But for right now, what we're learning to do is graph linear equations. And what we do in graphing linear equations for now is when we look at our equation, in number 6, it's x minus 2y equals 6. We pick out a value for x, and then we solve for y. Now, what I like to do is I like to look at what is the antecedent to the variable for y. And in this particular case, it's 2. So what I'm going to do is I'm going to pick numbers for x that are divisible by 2. The first one I'm going to pick, however, is always 0. I like that. That's real simple to solve for. The other two would be 2 and 4. You could also pick negative 2, negative 4, and we'll do that for some of the ones we're going to graph. Once we've picked those values, now we solve. In the first case, where we have x minus 2y equals 6, when we put a 0 in there, we get negative 2y equals 6, and dividing both sides by negative 2, we get 6 over negative 2, or y equals negative 3. Now, in the second case, where we have the x is equal to 2, when we substitute in this time, we have 2 minus 2y equals 6. Subtracting 2 from both sides, I get negative 2y equals 4. When I divide both of those by negative 2, I'll get 4 divided by negative 2, and I'll get y equals negative 2. Finally, in the last case, where I have x is equal to 4, I substitute in 4 minus 2y equals 6. And then subtracting 4 from both sides, I get negative 2y equals 2. And dividing both by negative 2, I get y equals negative 1. And you can see a pattern there. When I increase x by 2, I decrease y by 1. Now, the reason for 3 points is later on when you're doing graphing and you're doing it quickly, you'll only do 2 points. But in the beginning, we want to verify that indeed we've done our math correctly. All 3 points should line up. So let's go ahead and take a look at our points here. If we would, on our graph on the right, if x is 0, y is negative 3, that puts it down here. If x is 2, y is negative 2, so out 2, but negative 2 puts it here. And then if x is 4, y is negative 1, puts it right there. And if we have perfect graph paper, when we take those 3 dots and we connect the 3 of them, we should come up with a graph that looks sort of like that. Sorry for that little glitch there. And that's the way we graph it. We put an arrow in each direction showing that we have graphed that linear equation. All right, let's take a look at a couple more if we would. We're going to do number 12. In the meantime, I'm going to try and erase what we've done here. And hopefully we can get a few. It'll take a second here. There we go. And I may have to freehand things here a little bit. Extending our graph across. I got 3, 4, 5, 6, and 7. All right. When we look at number 12, what we have there is y equals negative 4x. Now, in this particular case, when I said let's do multiples of whatever happens to be the antecedent to the variable for y, just so happens that happens to be 1. There's nothing in front of the y, so we've got negative 4x. This time we'll set up our x and y axis. X, y. Again, I like to use 0. This time I'm going to use 1, and the other one is negative 1. Well, when y equals negative 4 times 0, then y equals 0. And what you'll notice here, and the reason I brought up number 12 is if we have something y equals something like 4x, negative 4x, that only x's and y's are listed, and there is no number listed, then what we'll find for problems like number 12 and number 11, and later down there at number 16 and number 18, 17 and 18, that our graph goes right through the origin. All right, so taking a look at the other two, if we have x is equal to 1, y equals negative 4 times 1, then y would be equal to negative 4. And then in the last one, if we had y equals negative 4 times negative 1, then we would have y equals 4. All right? Now I'm just going to plot the points. You can draw the graph, but 0, 0 is right there in the origin. And then if we go x is 1, y is negative 4. It's down in here someplace. And the other one, when x is negative 1, y is way up here someplace. And then you would connect those two dots, and it should be, you'll go right through the origin if you connect those properly. We won't do that so that we can move on to our next problem. Let's see here. All right. In the next problem that I've chosen, we're going to take a look at number 18. And again, in this particular case, what I'd use is the same, well, no, I'll take that back. Let's go ahead and take a look at that one. What I would use to start with is 0. That would be the same, because I know darn well that 0 times negative 1/4 gives me 0. So what would the other two values be? What I would suggest in this particular case is, since this is the fraction 1/4, I would use 4, and then I'd use negative 4. Because I know if I multiply 4 by 1/4, I'll get the whole number. So if I take y equals negative 1/4 x, and I use y equals negative 1/4 times, and I'll put 4 over 1, then these cancel out, and I get y equals negative 1. By the same token, if I use y equals negative 1/4, and I'm going to multiply it by negative 4 over 1, now these cancel out, but because I'm multiplying a negative times a negative, I get a positive 1. And there you go. And then all you have to do is plot those points, and when you draw your graph, that should go through the origin, because I have no numerical value that goes with it. Taking a look at two others that are on that page, what we want to look at is problems number 22 and 24. In 22, what it says is y equals negative 3. In this particular case, there is no even x variable there. So what you do is you go down to the point negative 3, and you just draw a horizontal line across. All right? So it would look a little like this. We go down to negative 3. And it doesn't matter if there's any value for x, because we would just have a horizontal line that goes across like this. Okay? By the same token, if we have x equals something, like we have x equals -2 and number 24, there are no y values, so we go to -2, and now, no matter what the y value would be, because there is none, we draw a vertical line like this. And I apologize again, I seem to have a little glitch there when I do that. But, so those are the ones for 22 and 24. Fairly simple and straightforward, but I wanted to show those to you. We're going to go ahead and erase those. And now let's go ahead and solve one over on page 417, where it has 2x plus 3y equals 6. All right, that's problem number 28, in case you needed to know that. 28 on page 417. I said for my x value, what I want is multiples of whatever is in front of the y. All right? What I'm going to do is I'm going to plot 4 points in this particular case, because what I like is always using 0. If I use 0 and I solve this, I get 2 times 0 plus 3y equals 6. And so now I get 3y equals 6, dividing both sides by 3. I get y equals 2. All right? Now, I said multiples of whatever happens to be in front of the y. So you say, well, what's a multiple of 3? Well, 3 is a multiple of 3. So I'm going to take and put in x equals 3 and see what happens. 2 times 3 plus 3y equals 6. 6 plus 3y equals 6. Subtracting 6 from both sides, I get 3y equals 0. And now if I divide by 3, it doesn't matter, so y equals 0. All right, let's take a look at another multiple of 3 and see what happens here. What if we pick 6? Okay, 2 times 6 plus 3y equals 6. That's 12 plus 3y equals 6. Subtracting 12 from both sides, now what I end up with is 3y equals -6. And now dividing by 3, I get -6 over 3, so y turns out to be equal to -2. See how the math works out so nicely with that? If you picked 1, then you'd be subtracting, 1 times 2 is 2, you'd be subtracting 2 from both sides, and you get 3y equals 4, and now you got a fraction. Plotting that is a little bit more difficult. But I said we wanted one more. And the reason I want one more is I want you to see that not only can you plot, or can you use a multiple in the positive direction, but you can also use a multiple negative value. This time I'm going to use -3. So if we take 2 times -3 plus 3y equals 6, now we have -6 plus 3y equals 6. By adding 6 to both sides, we now end up with 3y equals 12. And then 3y over 3 equals 12 over 3, and y equals 4. What if we do now plot all those points Let's go ahead and do that. X is 0, then y is 2. That's this one here. When x is 3, y is 0. That's right here. When x is 6, y is negative 2. That's down in here. And then when x is negative 3, y is 4. That puts it right up here, approximately. Now, this graph was done by hand. With your graph paper, when you plot these points, it should work out perfectly. But if I draw a red line basically through those 4 points, I should have a straight line through all of those. Okay? And that, notice I put an arrow at each end, that's graphing a linear equation.